This is a quick explanation how to set up a scope. So I have a dual trace one, and what I want to be doing is checking the phase shift, seeing what the phase shift is between the volts and amps. So you need a dual trace. One probe is going to measure amperage and one's going to measure voltage. Okay, it's not too hard to do. You take your probe that comes off your voltage, and you don't need to do anything with this, with the voltage one, and you hook this up to one of the AC lines feeding the motor, be it in an inverter or whatever. Because what I want to check here is what's coming into the motor. I want to see if there's a phase shift coming in. And there is, but we'll see that later. So there's two lines coming in. Here's one and here's two. One of them, you put the tip of the scope right on it. It's all connected, and just put it right on there. That's easy. That's the volts. The other AC line coming in, you want to have a resistor. This is a 1 ohm resistor. I could be using a 0.01, but I have a 1 ohm right now. And so the other AC line that feeds the motor, you just go, it goes right through the resistor. See that? And now the other probe, which is the current probe, that goes over here. Here's the voltage probe, and now here's the current probe. And you take the tip, and also this black ground clip, I guess you'd call it. So you have two alligator clips hooked up to this one, only one to this one. Leave this free. And the black clip goes on one side of the resistor, and the tip, which needs to be attached there, goes to the other side of the resistor. So that's not too hard. Now you just turn it on, and what will appear is what will appear right here. You'll have the volts and you'll have the amps together. You put it on dual, at least on mine. You have channel A or channel B or dual. And then important, you look and see what sort of square division you have. So I'm going to be on this one down here, 0.01, because I've done this already. Where is it? There it is, 0.01. That means that one of these squares is 0.01 volts. And in between are five spaces in between. So 0.01 divided by 5 is 0.002 volts. So each of those spaces represents 0.002 volts. Now, additionally, you want to know what your scope probes are. I have times 10 voltage. So when this shows, 0.002, it's going to be actually voltage 10 times that. Okay, and so both of my probes are times 10. And if you don't do that, know that, then you're going to screw everything up. It's going to look like it's 10 times less than it really is, which I have done before and recently. So know that. And now about the only other thing you can go wrong with is it's possible that these are switched around, and that'll have sort of the direction, sort of, even though it's AC, it's the direction will create a if you have a resistive load on it, like let's say a light bulb or something, it won't show a resistive load where the volts or amps are right on top of each other. Instead, it'll show 180 degrees off. It's pretty obvious when you see it. And so if it's 180 degrees off with a resistive load that you know is a resistive load, and the phases, the volts and the amps are like should be on top of each other, since it's a resistive load, not an inductive load with a phase shift. If such is the case, and it does not show in phase volts and amps, then you need to, well, that's how you want it to be when it's like that, and leave them how they are. But if it's not like that, if it's showing 180 degree out of phase volts and amps, then you need to just flip these around. Okay? And that'll screw things up because you think you have a huge phase shift and you don't, you know? So make sure you check with a resistive load and look at your scope and see if they're in phase or they're 180 degrees out of phase. And so you want to have it in phase. And that's where the white and the green, that's where the clips will be. Okay, so I'm going to turn this on. I have a problem. My scope is an old analog type, and it kind of makes a flashy it's kind of flashing. Like right now, I see with my eyeballs, I see a straight line here, but on my camera, I see a flashing here and a flashing here. So it's not catching everything. So anyways, that's the way it is. So here we go. I'm going to start this up. Wait one moment. Okay, like I said, with my eyeballs, I see a nice sine wave shape here. But this camera is like some digital function, and it just picks up what you see now. But anyways, right now I have this in channel B, which is volts, which is this yellow wire going to one of the AC lines. And if I flip this up to channel A, this is what the current looks like. Kind of triangular. But again, it's not there. You can kind of see it how it appears. And sorry, when I look at it with my eyes, it looks fine. Okay, so that's channel A, current, channel B, voltage, and now here's both. Dual, it says. And now this is what you want. Now, you want to have the peaks centered. So this is right down the middle. The peak, like let's say that there and there, like two spaces. So let's see. I can take my camera and move it down like this and move how it's going to look, but I'll try to get it here. Anyways, you want your sine wave to be split right in the middle. So if it's 2 spaces above for the peak, you want 2 spaces below for the peak. You know what I mean? The zero line has to be right down the middle of the sine waves. And when you take measurements of the phase angle, you do it at the zero line. You don't do it at the peaks, because there might be some slope or something going up. But you take your measurements at the zero line. And I don't know if you can see this. I'm going to put this in just voltage now. You see it's kind of it's a lot bigger than the current one, basically. Also, when you go to the like what the square divisions are, and like I say, I'm on 0.01, turn this adjustment knob all the way to the right. So make it as all the way to the right with that. Now, to make this smaller, I'm going to go over here to the voltage square divisions, which is at 5 volts. That means that for voltage, each of these is 5 volts. But remember, I have times 10 scope probes, so it's actually 50 volts. So I turned it down to 10 volts, which is actually 100 volts. I don't know. Anyways, so get these to be about the same size. So I'll put them on dual. I'm sorry it doesn't show up so well, but so you can kind of see there's the amperage is the triangular, then the voltage is curved. See if it appears again. And you get them so the peaks are close to being the same. Okay. Now there's a position where you can move. I'm moving the voltage up and down with this position. And I can move the current up and down. Okay, so let's get this. There's my current. Okay, so I think the current now is pretty well being sliced right in the middle by the zero line. And now let's get the voltage so it's about the same. Okay, there we go. Okay, now the phase shift. I'm sorry about this scope, but it looks great with my eyeballs. Okay, there's the phase shift between there and there. Let's see. I can do this sweep time, and I can kind of make it so it stays still. There, that's pretty good. Okay, there's the phase shift. This is the volts. Oh, it disappeared. There's almost at it. Anyways, what it's going to be is 2.75 small spaces here. You can count them. 1, 2, and then not 3, but just below 3. Here it is. Let's look at this one. Anyways, if I take a picture of this and then look at it for a while and blow it up, what I got was a phase shift of 2.75 spaces. The spaces being those small little small lines between one square division. So there's 5 of them. Okay, so the way you figure out the phase shift is not that difficult, except it's difficult to explain with this scope because it keeps doing what it's doing. But basically, you look at an entire sine wave from the 0 line to the positive peak, down to the negative peak, and back to the 0 line. So that's an entire sine wave. That's equal to 360 degrees. Okay, now you go to where it starts on the 0 line, the sine wave, and to where it ends, and you count how many spaces are in between. And I already know what this is going to be. It's going to be an 11.5. I'll count this. Like here's 5, here's 5, 5, 5, 11.5. From the beginning of the sine wave to the end on the 0 line. Now that you know how many spaces there are in one sine wave, and a sine wave is 360 degrees, now you divide 360 by 11.5, and that'll tell you how many degrees is one of these spaces worth. And I believe that is 32 and let me check with a calculator real quick. Okay, it's 31.3 degrees is 360 divided by 11.5. So if there are 2.75 spaces for the phase shift, you times that by 31.3 degrees, and that is your phase shift. And it comes out to be about 84.5 degrees. And when you have 90 degrees, you have a power factor of 0. That means volts times amps times 0. You have no power input. And so that's what it is that this is going to be. I've already done it. I wrote it all down, I made a video, but then I realized that I did these were not times 10. And so I said it was 0.12 watts, but actually it's 1.2 watts. So I deleted that video. Anyways, I guess, okay, this is just supposed to be a how to set up a scope video, but I went a little further with it, like how to analyze what you're seeing with a scope that you can't see. But really, on my eyeballs, I can see everything. Okay, I'm going to review really quick for somebody who's never done a scope before. Dual trace, one over here is amps, one over here for volts. This comes off of here, this comes off of here. The voltage, you go to the tip, you leave this blank, you bring that voltage over to one of the AC lines coming in from the grid or the inverter. Because I want to measure what's going into this thing. I want to see the phase shift going into it. I want to see the amps going into it. Okay, now that's simple. The voltage probe just goes to one of the AC lines. The AC line's connected, but you connect it like this to it, you know. Now the other one is a little more difficult, but it's not that difficult. You take the tip and you put it on one side of this resistor. This is a 1 ohm resistor, or you can have a 0.01. And the power on this other AC line coming in from the grid also goes straight through the resistor. Okay? And into the motor. And now you put the tip is the white wire that goes on one side of it. The green wire is this black clip, and that goes on the other side of the resistor, just like that. And like I was saying, if you got it this wrong, you're going to have this huge phase shift, which doesn't make any sense. And the way you test is like with a light bulb, a known resistive load, and it should be all no phase shift at all, just volts on top to amps. And if it's wrong, flip these around like that. Very simple. Well, maybe I can show. Okay, you see what the phase shift is here now. I know what it should be because I've done this already, and it should be what it is right now. About that big. See that? But watch when I'm going to go over here and flip this around. This is a big mistake I made in the past. I thought I had this incredible phase shift with my bit transformers. Super stupendous thing going on, but it was actually, I had these clips backwards. Okay, now I have these clips backwards now. Now remember what the phase shift was? Look what it looks like now. It's quite craziness. Wish you could see the whole thing. But that's not, so I'm going to put them back. And what you're supposed to do is set up your scope with a light bulb. You're measuring a light bulb, and see what that looks like, and make sure it's in phase. Okay, maybe somebody could actually be able to do a scope for the first time after watching this, maybe not. But that's how you do it. Okay, thanks for watching.